Hello everyone, in this video I'm going to discuss the example for limit and continuity. Given the function, so kindly illustrate the situation in a real number line. So here we have the real number line, then we have the value 0 and 4. So for x less than equals to 0, we have the function 1 plus exponent x. Next, we have 0 until 4, where 0 is not included, we have the function x plus with the 6 over 3 minus x. Then, for the value x greater than 4, where we have the function c. If the situation x is equals to 4, then we have the function x plus 6 over 3 minus x. So here we have the situation. A. Determine whether the function fx is continuous at x is equals to 0. So step number 1, f0. So we are going to substitute 1 plus exponent 0. So f0 is equals to 2. The situation is defined. Second step, limit when x approaching 0 from the left. Limit when x approaching 0 from the right. So substitute the function. So we have 1 plus exponent x. If we substitute 0, and we will have the value of y approaching 2. Next, when x approaching 0 from the right, we have the function x plus 6 over 3 minus x. So if we substitute the 0, and we will have 6 over 3, the value of y will be approaching 2. So limit when x approaching 0 from the left for the function fx is the same for the limit when x approaching 0 from the right for the function fx. Then we can say limit when x approaching 0 for the function fx, the value of y will be approaching 2. So we can say the limit exists. Step number 3, f0, limit when x approaching 0 for the function fx. So the value are the same. Then we can say the fx is continuous at x is equals to 0. Kindly refers to B. Given that the function fx is discontinuous at x is equal to 4. So determine the value of c. So number 1, so we have f4. Kindly substitute the value. We have 4 plus with the 6 over 3 minus 4. So the f4 will be equals to 10 over negative 1, where we have the negative 10. So we can say define. Second step, limit when x approaching 4 from the left for the function x plus with the 6 over 3 minus x. So if we substitute the value, and we will have 10 over negative 1. So we have the value of y approaching negative 10. Next, limit when x approaching 4 from the right. So we have the function c. So the situation mentions that it is discontinuous. So meaning that limit when x approaching 4 from the left for the function fx shouldn't be the same when x approaching 4 from the right for the value c. So the situation is discontinuous. So the limit for both sides must not be the same. So the value of c cannot be equals to negative 10. Or we can say the c must be equals to negative 10. Then only we can say fx is discontinuous at x is equals to 4. So the value of c can be any value except negative 10. So negative infinity until negative 10, union start from negative 10 until infinity. So where the negative 10 is not included. Kindly refers to c. Find the vertical asymptote. So by referring to the function x plus 6 over 3 minus x. So here we have limit when x approaching 3 from the left. Limit when x approaching 3 from the right. So for the function x plus with the 6 over 3 minus x. So x plus 6 over 3 minus x. So if we substitute the 3 from the left, for example, we have 2.9999. So if we substitute, and we will have the positive value over, if we substitute for the denominator, and we will have positive value as well. So limit when x approaching 3 from the left for the function x plus 6 over 3 minus x. So we will have positive infinity. For the 3 from the right, so we are going to substitute 3.0001. So here we will have a positive value, and here we will have a negative value. So limit when x approaching 3 from the right for the function x plus 6 over 3 minus x. So we will have negative infinity. So the vertical asymptote is x is equals to 3. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.